When solving this graph sketching problem, I'm going to go through and sort of show you how you can pick out all of the important pieces. So the first step is going to be to look at these asymptotes. So whenever I see the limit as x is going to either plus or minus infinity, giving me some number, I know that gives me a horizontal asymptote. So this first step is going to be to draw those horizontal asymptotes. Because they're different from my positive infinity or negative infinity, I'm just going to draw them on one side of the graph. So as x is going to positive infinity, I know that my function is going towards 3, so I'm going to draw this horizontal asymptote at 3 for the positive x's. And as x is going to negative infinity, the function is going towards negative 1, so I'll draw that in there for negative 1 as well. It's important to remember that this is just telling us what's happening at the end of the function. So at the end of my function, I have to be going towards this line, either from above or below. So I don't actually know which one it's going to be yet, but I can kind of draw that little function bit right there on that line. In the middle of the function, I am allowed to cross that horizontal asymptote as long as I want. Okay, step 2 we'll do in green here. So I want to draw in my vertical asymptotes. So that's where the function can go up to infinity. So at x equals negative 4, I have a vertical asymptote. And at x equals 2, I have one of those as well. So I know for vertical asymptotes, you have to go up to infinity on one side of that asymptote, and you can't cross it. Step 3 here, we're going to put in the increasing and decreasing information that we get from our derivative. So we remember here that if you have a function f, when the derivative is positive, the function is increasing. When the derivative is negative, the function is decreasing. So I'm going to be decreasing for that first set of intervals. So I'm going to actually just use down arrows to represent decreasing here. So I'm going to be decreasing until negative 4. And I'm just putting this at the top to kind of remind me. Decreasing between 0 and 2. And then decreasing from 2 to infinity. So I'll pop in all of my decreasing information here. And then the derivative is positive between negative 4 and 0. So that tells me that I'm increasing. So I'm going to be going up there. And then right at 0, the derivative is undefined. So I might have a corner, cusp, or a vertical tangent there. Corner, cusp, vertical tangent. Or it could just be discontinuous. Okay, so that's from my derivative information. In 4, the second derivative tells us about concavity. So if the second derivative is positive, that means my function is concave up. So I've got that cup up shape. And if it's negative, then I have that concave down, frown down. So I'm going to be concave down from negative infinity to negative 4. So I'm just going to draw this frown down. I'm also concave down from negative 4 to negative 2. I'll stop there at negative 2. I switch to being concave up. So I'll draw my little concave up shape until 0. Between 0 and 2, I'm concave down again. And finally, I'm concave up at the end. Okay. The last thing we have is some specific points for our graph. So I know that it passes through the point negative 2, 0. So I'll put that in there. 0, 4. So I'll put that in there. And 1, 0. So I'll put that in there. And now I just need to go and see if I can connect all of this information I have to draw a nice graph. So I should start at my asymptote. And I need to go concave down, decreasing. So I'm going to be decreasing concave down towards my next asymptote. So asymptote to asymptote, decreasing concave down. Next, I need to figure out where to start at my next asymptote. So I could either start from the top here or from the bottom, or I could actually start somewhere in the middle as well, because for an asymptote, it only needs to be going towards positive or negative infinity on one side. I know I want to be increasing, so I shouldn't start at the top because I won't be able to increase from there. So let's start at the bottom, and I'll be increasing concave down, and I'll just head towards that point. Now I need to keep increasing, but be concave up towards my next point. So I'm increasing concave up towards that next point. Now I need to be decreasing concave down. So that's going to be this shape here. And if I notice, I ended up with a corner there, and that's why my derivative was undefined. I need to now continue to be decreasing concave down. I'm heading towards an asymptote, but because I'm concave, ooh, sorry, let me go back. I drew the wrong shape. Undo, undo. I drew it concave up instead of concave down. So I'm going to fix it. I'm just going to go back in time here a little bit. I needed to draw concave down decreasing. So concave down decreasing should have looked like this. Decreasing concave down. And now I'm going to continue to decrease concave down away from that point. So I can maybe try to make it look a little smoother there. Towards my asymptote. And now at the other side of the asymptote, I want to be decreasing concave up. So since I'm decreasing, I'll start here at the top, concave up towards my last asymptote. So we just have to put all of those pieces together on our graph. Let's do one more graph sketching problem. So we're given that the domain of our function is all numbers except for -2. The limit as you go towards 2 from the left is infinity, but from the right is -infinity. The limit as you go towards -infinity and positive infinity are both 1. And then we have information about the first derivative, when that first derivative is positive and when that first derivative is negative, and some points the function passes through. So if you haven't had a chance to already, I encourage you to work through this problem on your own. And when you're ready, come back and watch the solution. So the first thing I'm going to do is I can maybe indicate that the domain does not include -2. So maybe I'll put a little open circle there just to kind of indicate that to begin with. But then we see that as x goes towards -2, from the left I go towards infinity. Because the limit as I approach -2 from one of the two sides is infinity or -infinity, I know that I have that vertical asymptote at -2. So as I go towards -2 from the left, I'm going up to positive infinity. So I'll indicate that with a little function heading towards positive infinity at the top. And as I go towards 2 from numbers bigger than -2, towards -2 from numbers bigger than -2, I'm going down towards negative infinity. So I'll indicate that by a little piece of the function at the bottom. We also know that as you go towards both plus and minus infinity here, the function is heading towards 1. So I'll go ahead and put in that horizontal asymptote at 1. So we indicated that. The first derivative is positive between -infinity and -2, which means the function is increasing from -infinity to -2. It's also increasing from -2 until 4. So let's indicate 4 on our x-axis, and I'll have it increasing all the way out until I get to 4, and then starting at 4, it's going to decrease because that first derivative is negative there. I also know that the function passes through the points 0, 2. So I can put that, let's put that in pink, 0, 2, and 4, 4. So let's move 2 down a little bit so I'm not too much off the screen here. So let's call this guy 2, and then over here I'll make that 4. Okay, so now we have our information, and we're just going to go through asymptote to asymptote. So I'll start here. And I want to be increasing until this next asymptote. We don't have any information about the second derivative, so we don't need to worry about concavity information here. So I'm just increasing towards that. Here I know I have to start at negative infinity, and I have to increase. So I'm going to increase towards that point, 2, and then continue increasing, but end up over here. So maybe I should increase, but not as fast, so I'm not going to run out of space before I get to that point 4. So I can be increasing towards that 4. And then after that, I'm going to decrease. So kind of move that there. After that, I'm going to decrease towards my asymptote. So one of the things to notice here is that we do cross our horizontal asymptote. That's okay. You are allowed to cross horizontal asymptotes. You just have to get close to them at the ends. So I can check. My domain is every number except for -2. I have my one-sided limit information going towards positive infinity from the left, going towards negative infinity from the right. I've got my increasing, decreasing information as indicated, and I crossed through the points I was supposed to. So that would be an appropriate graph here. There's many options that you could have. Yours might look different, but as long as it satisfies those 5 conditions, you're good. Let's look at one more example here. Again, if you haven't had a chance to go ahead and try this one on your own, I encourage you to do that. I've got a little bit of my axis drawn here. So let's go through and just read off the pieces of information we know. So the domain is all real numbers, so I want to make sure that I draw it everywhere. The limit as x goes to infinity is 1, and as we go towards negative infinity, we get 3. So as I go towards infinity, I'm going to have that horizontal asymptote at 1, and I go towards negative infinity, I'm going to have that horizontal asymptote at 3. So remember, these horizontal asymptotes are just giving me that end behavior. So at the end, my function should end up somewhere at 1 in the positive direction, and it should end up somewhere near 3 in that negative direction. So that's my asymptote information. The first derivative is positive from negative infinity to 4. So let's put in, I notice x values of 4, 5, so maybe we'll go out to, say, 6 or 7 here. So let's call that 1, 2, 3, 4, 5, 6, 7. So I'm going to be increasing until 4. So I could, again, just draw some up arrows here, increasing until I get to 4. And then after that, the derivative is negative, so my function should be decreasing. The second derivative here is positive from negative infinity until 0. This means my function is concave up until 0, and then concave down from 0 to 5. So it's a little bit past 4 there, and then it's going to be concave up again afterwards until infinity. And the function passes through the points 0, 5. You go put those in a different color. 0, 5, 4, 7, and 5, 6. So let's go ahead and see what we can get here. So I'm going to start at my asymptote. I'm going to be increasing concave up. So I'm going to have this increasing concave up shape towards my first point, 5. When I get to 5, I want to still be increasing, but now I want to be concave down. So I'm going to increase concave down until my next point. At that point, I switch to decreasing concave down. And finally, I switch to decreasing concave up to get the rest of my function. So if we check, the domain is all real numbers. We have the function drawn everywhere. As we go towards infinity, it's heading towards 1. But as we go towards negative infinity, it's heading towards 3. I'm increasing until x equals 4, and then decreasing after x equals 4, because the first derivative is positive and then becomes negative. My function is concave up to begin with, end to end, and it's concave down between 0 and 5. And then we have that function passing through all of those points that we needed it to pass through. So we have all of that information that we need.